Okay, welcome to this video where we're going to be having a look at a paper 3 practice paper. So for this paper we are going to be using a calculator. It is going to be 80 marks and we are going to be going through this pretty quick. This is obviously a almost last day revision video, so I don't want to spend too long going over each question, but instead I will put links to all of the topics in the description and timestamped for you, which I'll show you in just a moment. So as I said, this is going to be quite a quick video, so be prepared for going through this pretty quickly, and feel free at any point to obviously pause the video and make any notes if you need to. Now we've got a lot to get through, so before we get started, I am just going to quickly show you how you can go about finding all the additional links and revision videos that you need towards this exam. So when you're on the channel, if you click into the playlists, you'll see that the playlists are right there ready for you to go into. So if we click into the Edexcel playlist for this exam revision and have a look at what's inside there, you'll see that all of the videos that I've made are right there for you to access. You've got just there every topic on the paper 2 maths exam for foundation and for higher, and obviously there's the ones for paper 3 in there as well. If you keep scrolling down, you've got videos on how to use all of the formulas. You've got videos on some of the hardest topics, if we carry on down for paper 2. And then you've got a whole series of short revision videos based on some of the tricky topics that are on that revision list. So there's everything in there for you to access, so make sure that you know how to use the playlists. If we click into one of these videos as well, we'll click into the Everything on Paper 2 video, you'll see in there all the additional stuff that you can access as well. So let's have a look at the Every Topic on Paper 2 higher revision video. Okay, so when you're on this video, you can click into the description and you can scroll down and find everything you need. You'll see at the top there that you have links to the hardest videos or the hardest topics video. You've got the practice booklets and the revision checklist for you to download there. You've got all the links for all the foundation and higher exams. You've got the entire quick revision series and all the links there. And you've got all my larger revision videos as well that you can go into. If you keep scrolling, you'll see that I've timestamped every single topic and a full lesson next to each topic as well. So there is literally everything that you could possibly need for your revision. Let's say, for example, you get down to an hour and 22 minutes, so you're struggling on circle theorems. You can see that circle theorems is just there, and there's a full lesson next to it, and inside that lesson there's further links for more circle theorems as well. So absolutely everything is there. It's all laid out really nice and clear for you. Obviously you just need to know how to use it, which is why I'm just showing you, hopefully nice and quickly here, how to use these videos. So I hope that's useful and helpful. If it is, don't forget to like, don't forget to comment, don't forget to subscribe. But we've got a lot to get through here, so let's get started. Okay, so looking at our first question. It says here the table shows information about the heights of 80 children, and we've got the table below. It then says find the interval that contains the median. So when we're finding the median, we'll take how many children there are, we'll divide that by 2 to find out around about where the middle is. So that'll be around about the 40th child. So if we work down our table, we start with 4. When we add the next 11, that gets us to 15 children. When we add the next 24, that gets us to 39. And then you can see that that 40th person is going to be in this class just here. So that's where the 40th will be, and that's therefore where our median will lie. So the class that our median lies in is this one just here, and that is from 160 to 170. So there is working out the median class. You could be asked to work out the modal class, and that's a lot easier. You just find out which one's the most frequent, which would be this one with the 24 in. So the modal class would be 150 to 160. Obviously this was asking for the median class though. So part B here, it says draw a frequency polygon. So when we're drawing a frequency polygon, it's nice and easy to draw. We use the midpoints and just plot it against the number. We join them together with nice straight lines. So 135 will go to 4. So just read the scale very carefully. There is 4. and then it's going to go up every 10 from there, so 145, 155, etc. And we've got 11, 24, 22 and 19 So 11, just there, 24, in fact let's just check, yeah it was 24, 24 will be just 4 above the 20, so that is 1, 2, 3, 4, then 22, and then our last one was 19. So for the last one there, just one below 20, 19, and then you get your ruler and your pencil, you join these up with nice straight lines. Not the easiest for me to do on here, but I'll do my best. And there we go, there is your frequency polygon. So there we go, there is question 1. Question 2, it says there are 60 people in a choir. Half the people in the choir are women, and the number of women in the choir is 3 times the number of men in the choir. The rest of the people in the choir are children. The number of children in the choir to the number of men in the choir is n to 1. Work out the value of n, and you must show how you get your answer. So if there are 60 people in a choir and it says half of those people are women, so 1/2 of 60 is going to be equal to 30. So we know already that if we were to write this, let's say as a ratio, let's say women to men to children, there would be 30 women. It says the number of women in the choir is 3 times the number of men in the choir, so we would divide this by 3, and that would be 10 men. And we know there are 60 people in total, so that adds up to 40 at the moment, so there must be an additional 20 children. So now it's said that the ratio of children to men is n to 1. So if we write the ratio of children to men, the number we had for children is 20, the number we have for men is just next to it, 10, so our ratio is 20 to 10 at the moment. Now we want to write that in the form n to 1. Now if we want to get it in the form n to 1, we're just going to divide by whatever number is sitting in that position where the 1 needs to be. In this case it's 10. So we divide both of these by 10, left and right, and you would get 2 to 1. Now that would be our answer, because the value of n, as we can see, is 2, so n would be equal to 2. Now that was quite a nice simplification of ratio there. What you could have is quite nasty numbers in that ratio, but whatever that number is sitting in the 1 position, you just divide both sides by that number. But obviously this has appeared on question 2, so it's not the most difficult simplification of a ratio there. Okay, on to question 3. So it says Natalia pays £13,995 for a car and Lauren pays £14,495. We've got a rate of depreciation for Natalia of 12%. We've got a rate of depreciation for Lauren of 13%. And it says work out whose car will have the greater value at the end of 3 years. So when we're doing depreciation, particularly as we're using a calculator, we want to use a calculator approach. Rather than working out 12% and keep taking it off each year, we just need to think about what percentage that's going to be after a 12% reduction. So when we have 100% and we take away the 12%, that leaves us with 88%. So if I want to just straight away multiply to get 88%, I just need to use the decimal version, which is 0.88. Again, you could divide that by 100 to get that number, but hopefully you recognise that 88% is the same as 0.88. So for Natalia, which we'll just label with an n, we've got 13,995 that we're going to multiply by 0.88. Now if that's happening over a 3-year period, we would do that to the power of 3. But of course you could just times it by 0.883 times, but obviously much slower and you're going to have to keep writing it down. So if I just type that into my calculator, I straight away get my answer for Natalia, and it comes out as £9,537, and to the nearest penny it goes to 20 pence. So there we go, we have the value of Natalia's car. If we now work out Lauren's car, we're going to take the same approach, but her car obviously has a different value, 4,495, and her rate of depreciation is 13%. Take that away from 100, that leaves you with 87%, so that would be 0.87. So we would multiply by 0.87 instead, and that is again going to be to the power of 3. So if we type that into our calculator, 14,495 multiplied by 0.87 cubed, that gives us a value of, and it's very close, 9,545, and that's 0 pence to the nearest penny. So if we have a look, the question said whose car has the greater value at the end of 3 years. So Natalia's car was 537, after that 9,000, and Lauren's is 545, so that 45 is just that little bit bigger. So we would say Lauren's car has the greater value, okay? So obviously I'd write a full sentence there, but Lauren's car has the greater value, and obviously you've got your working out nicely backed up there to show that this one is the larger number on the bottom. Okay, so part B has another element to it. So it says the rate of depreciation assumed for Natalia's car was too low. How does this affect the value of her car at the end of 3 years? Well, if Natalia's car actually had a higher rate of depreciation, because obviously at the moment it's 12%, let's say, for example, actually it was 20%. Now, if it was 20%, the value of her car would have been much lower. So that's all that we need to say. So the value of her car would be less. There we go. You could back that up with some numbers if you want. If you want to obviously sort of think about it yourself and you're not sure whether it goes up or down, but the value of her car would be less. And there we go. And there we go, 1 mark, so we don't need to do any working out with that. Okay, on to our next question. So it says here, in a sale, the price of a TV is reduced by 25%. A week later, it's reduced by 15%. The price of the TV is now £293.25. What was the price of the TV before the sale? Okay, so this is a reverse percentage. So we're going to use a similar approach here. You can use a bar method. I normally use that for non-calculator methods. When we have a calculator, we can do this in a much quicker way. But if you prefer the bar method, you can use that as well. So it says here, a TV is reduced by 25%. So we started off with the cost of a TV. Now it was reduced by 25%. We already know from depreciation, to do that, we would multiply by 0.75. That's just 100% take away 25% as a decimal. So we would have times by 0.75. We'll have then got a new value, and then a week later it's reduced by 15%. So if we take that away from 100, that would be 0.85. So then we would times our answer by 0.85. So it's gone into 2 stages, and then it gives us this value at the end, which is 200. That is not a 2, so let's write that again. 293.25. Now, if we want to work backwards through these steps, all we have to do is reverse this process. So instead of timesing by 0.85 in that second step, we would divide by 0.85. And then to get back to the original number, obviously rather than timesing by 0.75, we'll divide by 0.75. So if we write that just here, divide by 0.85 and divide by 0.75. There is a way of doing this in one step, but I don't think it's necessarily necessary for this question. So let's do 293.25 divided by 0.85. And that gives us a value in the middle here of £345. We could then divide that by the 0.75 and it finishes us off in or with a value of £460. So our final answer for this question will be £460. And there we go, that is just reversing a percentage decrease. You would do the same if it had gone up in value. So let's say, for example, it had have gone up by 25%. Well, in that scenario, let's just label it sort of scenario 2. If it had gone up by 25%, we would have timesed by 1.25. And if it had then gone up by 15%, we'd have timesed by 1.15. So we'd have just reversed that process in exactly the same way. We'd have divided by 1.15 and then divided by 1.25. That's obviously if it was going up in value, so not if it was a sale. There we go, just another idea if it was phrased slightly differently. Okay, so this question looks like we're going to have similar shapes. So it says ABC and EDC are straight lines. EA is parallel to DB, and we can see that on the diagram because it's got our parallel line symbols. So these are parallel. Now it says some lengths that we need to add on to here, but it doesn't say anything about the lines being similar. So we need to know by looking at this diagram that these are similar shapes. Now we know that they're similar shapes because we have the triangles overlapping each other, and that means they have a shared angle. So this angle just here is the same in both, as it is shared. Because these lines are parallel, that means that we have some corresponding angles. We have this angle here, which is equal to this angle here. And we also have this angle just up here, which is corresponding and equal to this angle just here. So we know that all of the lines, or all of the angles, are the same for all three angles in the triangle. And if that's the case, we know that they are similar triangles. So we can go about actually working out the lengths in here by thinking about this information that we've got. So it says E to C, the full length is 8.1. So this is 8.1. D to C, just from there to there, is 5.4. So we have the corresponding lengths now on both triangles. D to B, this one just here, is 2.6. Work out the length of A to E. So we're working out this one just here. Let's put an X next to it. So when we're doing this, we want to work out the scale factor. So I want to take the large length, which is the full length of the triangle here. And again, you can redraw these triangles separately if you prefer to visualize it like that. And we're going to divide that by the smaller triangle length. And that will give us our scale factor. So 8.1 divided by 5.4 will give us our scale factor. So let's work that out. 8.1 divided by 5.4 gives you 1.5. There you go, it comes out as 3 over 2. But as a decimal, that's 1.5. So to move between the lengths, we're going to times or divide by 1.5. So here we are working out the larger length. So we're going to times by 1.5. And if we work that out, 2.6 times 1.5, we get an answer 3.9. So there we go, our final answer for part A is 3.9. Now part B gives us some more information. It says A to C is 6.15. Work out the length of A to B. So A to C is the full length going down this side of the triangle, and that is 6.15. And it wants us to work out the length of A to B, which is a little strange because it's the gap in between them. But if we work out the length of B to C, the smaller triangle, then we can work out the gap. So we're going to work out this length to start with. So to get to the smaller length, we'll use the same scale factor, but we're going to divide by 1.5. So 6.15 divided by the scale factor gives us a length 4.1. So if we want to work out the gap in between them, this bit just here that we've highlighted, we take the full length, 6.15, subtract the smaller triangle, which is 4.1, and that leaves us with a length of 2.05. So the length of A to B for that final part there is 2.05. Okay, on to our next question. Okay, so we have got some simultaneous equations, and we've also got negative numbers involved. So when we're doing simultaneous equations, I like to make the coefficient of y the same, but of course you can do this with the coefficient of x as well. So I'm going to focus on these two numbers. So I'm going to times the top equation by 5 and the bottom equation by 6, and that's going to make the coefficient of y become 30. So that would make my top equation 20x plus 30y, and that is going to equal 25. The bottom equation, 7 times 6 is 42, so that's going to be 42x plus 30y, and that now equals a negative 10.5. I probably would type into the calculator just to make sure I get that right, but it comes out as minus 63. So now we've got our two equations with the same coefficient of y. I just need to decide whether to add or subtract. Now the coefficients that are the same also have the same signs. So when they have the same signs, we will subtract. Now it's a little bit strange because you can either do the top divide, take away the bottom, or the bottom take away the top. Either way, we've got negatives involved. So I'm going to do the bottom 42x, take away 20x. And that gives me 22x. The 30y's disappear. And then I've got negative 63, take away 25. Obviously we're doing this on a calculator, so that's easy enough to do. It comes out as negative 88. So there we go. I now need to divide by 22 to get the value of 1x. So 1x is going to equal negative 4. There we go. Almost forgot to write my negative there. Negative 4. And there is the first part of the answer. To finish this off, I need to find the y value. So I'm going to pick one of those equations. I think it's probably easier if I pick this first one. So 4x plus 6y equals 5. So that's 4 lots of negative 4, which we've just worked out, the value of x, plus 6y is equal to 5. 4 lots of negative 4 is negative 16. So negative 16 add 6y is equal to 5. So to solve this, I need to add 16 to the other side as it's negative 16. So 6y is equal to 21. And then, just like before, I'm going to need to divide by 6. So y will be equal to 3.5. And there we go. There is our final answer. So down here, x is equal to negative 4 and y is equal to 3.5. And there we go. There is our simultaneous equation. Question 7. It says A and B are two sets of traffic lights on a road. The probability that a car is stopped by lights A is 0.4. And we've got some more information. Let's put that onto our diagram straight away. So stopped by lights A was 0.4. So lights A is this first branch. So that's 0.4 and this will be 0.6 as they have to add up to 1. It then says if a car is stopped by lights A, then the probability that the car is not stopped by lights B is 0.7. So if it's stopped by lights A, that's on this branch. So the probability it's not stopped by lights B is 0.7. And therefore this would be 0.3. On to the next piece of information. If the car is not stopped by lights A, the probability it is not stopped by lights B is 0.2. So down the bottom, 0.2 and 0.8. And there is our probability tree completed. It says Mark drove along this road. He was stopped by just one set of traffic lights. Is it more likely he was stopped by lights A or stopped by lights B? And you must show your working. So if he's only stopped by one set of traffic lights, he could be stopped by lights A and then not stopped by B, or he could be not stopped by A and getting stopped by B. Now when we're working out routes on a probability tree, we just multiply the pieces that it goes through, whether they're fractions or decimals. These are decimals, so we need to just do 0.4 times 0.7, which is 0.28. And for this one here, we've got 0.6 multiplied by 0.8, which is 0. And that's going to be way higher. I'd have thought that they would have been closer than that. But there we go, 0.6 times 0.8 is, and you obviously use your calculator if you don't want to do these in your head, 0.48. So there we go. It is much more likely that he's going to be stopped by traffic light B. There's only a 28% chance that he's going to be stopped by lights A, and there's a 48% chance that he's going to be stopped by lights B. So there we go. That would be our answer there, and we would write that. Obviously, we could write that working out down here or next to the tree. So it is more likely he'll be stopped by lights B. Okay, you'd write that down. More likely to be stopped by lights B. There we go. And obviously you could point that towards your working if you wanted to. Right, okay, there we go. So there is our probability tree. Okay, so we've got some average speed. Now obviously with average speed questions, there's a lot of different questions that you can have. You can have those kind of questions where there's a mixture of journeys, and you can have obviously average speed mixed in with things like bounds. So I'll link obviously the videos in the description for that, particularly for this one where you've got journey mixtures as well. That's definitely worth checking out. But this question says Lara is a skier. She completed a ski race in 1 minute 54 seconds and the race was 475 metres in length. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long Lara should take to complete a 700 metre race. Well, for this then, let's work out her speed. So speed is equal to distance over time. You can either use your formula or a formula triangle, and for working out speed, we do distance divided by time. So that would be 475, and we're going to divide that by the time. Now the time is currently written in meters and minutes and seconds, so we want to convert that just into seconds. So if I do that, again you could do this in, you could convert it into minutes as well, but I think it's going to be easier in seconds. So that is 60 seconds in the minute plus 54, which gives us a total of 114 seconds. So if we divide by 114, 475 divided by 114 comes out as, and it's not the nicest of numbers, 4.16 with a recurring 6. So now, if her speed is going to be the same, how long would it take her to complete a 700 metre race? Well, again, we're going to do speed, distance, time. We now have her speed, we have her distance, but we're working out her time. So I'll cross off time. So we're going to do distance divided by speed. So it's 700 divided by this 4.16 recurring. Obviously keep this number in your calculator, because now I can just type in 700 divided by and use the answer button. So when I do that, it comes out as 168. So there we go, and that is in seconds, as we were working in seconds. So there we go, it's going to take her 168 seconds. It does say to write your answer in minutes and seconds. So we just need to convert that. So 60 seconds is 1 minute, 120 seconds gets you to 2 minutes, and then we've got 48 seconds left over after that. So it's 2 minutes and 48 seconds, and that's our final answer. It now says Lara's average speed actually increases the further she goes. How does this affect your answer to part A? Well, if her average speed increases, then she will have obviously done this faster, as she'll be going a faster speed. So how would our answer be affected? Well, our answer was a time, so we would have a faster time, okay? So I would write down Lara would have a faster time. There we go, it's going to write faster time. Okay, on to our next one. Okay, so in this question we are rearranging the subject. So it says here, make k the subject of the formula. So it says m is equal to the cube root of, and then we have k cubed plus 1 all over 4. Now everything at the moment is locked in by this cube root. So we need to get rid of the cube root to start with. So to do that, cube both sides. So we would have m cubed is now equal to, and the cube root is gone, so we just have k cubed plus 1 all over 4. Now we have a fraction, and everything is locked in by this divide line. So I want to get rid of that divide, so I'm going to times both sides by 4. So I would have 4m cubed is equal to k cubed plus 1. Now I'm going to subtract the 1. I'm going to write down my steps each time, so minus 1, and that would give me 4m cubed minus 1 is equal to k cubed. And now I can finish it off. To get k on its own, I just need to cube root both sides. So I would do the cube root of 4m cubed minus 1, and that is equal to k. And there we go, there is our formula rearranged. It doesn't matter that I have k on the right, you can write it on the right or the left, absolutely fine whichever way you decide to do that, but there we go, that would be our final rearranged formula. Now that formula there didn't involve any factorisation, but you could have questions where you have to actually factorise, or you could have things like this where you've got square roots and cube roots to deal with. But I'll link the video for the changing the subject of a formula where you have to factorise as well, and they're very much worth looking at. Okay, question 10. So we've got the vector A and the vector B are shown on the grid, and we can see those vectors there. It says on the grid, draw and label vector minus 2A. So our vector A is just here, it's going upwards. If I want to draw minus 2A, it's going to go double that distance and in the opposite direction. So having a look at that vector there and looking at the pattern, it goes sort of across 1 up 2. Okay, I've tried to draw on the outside of the lines there. So if we're going to do that, we're going to be going across 1 up 2 in the opposite direction, but across 1 up 2. So it's going to go from there to there, and that's 2 times the distance. And there we go, without a ruler and a pencil, it's going to look something like that. Now minus 2A means it's going now in the opposite direction. So we draw our arrow the other way, we just label that as minus 2A. And there we go, that would be our vector. It then says work out A plus 2B as a column vector. So looking at these vectors that we have here, the first vector, A, goes across 1 and up 2. So as a column vector, that would be 1 and 2. So that's right 1, up 2. For B, this is a little bit different as it's going down. It goes right 1, down 3. So that would be 1 and minus 3. So that's the vector A and the vector B. So if I want to do A plus 2B, well, A was 1 and 2, and I want to add to that 2 lots of B, and B was 1 and minus 3. So 1 and minus 3. So before we add these together, I just want to double that second one. So it's going to be 1 and 2, add, and if we double those numbers, 2 and minus 6. Now adding those together on the top, 1 add 2 is 3, and 2 and minus 6 is minus 4. So the total vector there would be 3 and minus 4. And there we go, there is our final answer looking at some column vectors. Question 11. says Tracy is going to choose a main course and a dessert in a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways of choosing a main course and a dessert, you need to add 8 and 7. Is Tracy correct? You must give a reason for your answer. So this is the product rule. When we're working out a total amount of combinations, we pick the total amount of combinations in the first pick, which is 8 main courses, and the total amount of choices from the second pick, which is 7, which times them together. So we would just do 8 times 7. So Tracy has obviously said you need to do adding 8 and 7. So no, she is incorrect. She is incorrect. So is Tracy correct? No. You would say she should multiply 8 and 7. There we go. And there we go, there's our answer. You wouldn't need to actually work it out unless it asked you to. We're just stating if she's correct or not. Obviously a reason. The next one says 12 teams play in a competition. Each team plays each other team exactly once. Work out the total number of games played. Well, what we have here is 2 games that are going to be played. So in the first pick, there are 12 teams. They can't play themselves, so on the next pick, they're only going to be able to play against 11 other teams. So we would times them together. So 12 times 11 is equal to 132. Now in this particular question, it says each team plays each other team exactly once. So for this particular one here, we are going to have to do something to the answer, because at the moment this includes things like team 12 playing team 11, and then on another option, team 11 playing team 12. So it incorporates the fact that they'd be playing each other twice, or have 2 different combinations where it's 12 and 11, or it's 11 and 12, which is obviously the same thing when you're playing games against each other. So with this one, we actually have to halve our answer. So for this, we'd do 132 divided by 2, which will actually give us 66 games that are going to be played. So that's one of those interesting ones there where you have to halve your answer, because actually we didn't want those double ups. It's a little bit different sort of if it was 12 cards that you're giving one card to someone and then you're going to give a card to somebody else. Well, they can have the same 2 cards and swap them over, and that'd be different because person A would have, let's say, card 12, person B would have card 11, and that'd be different if you swap them over. That'd be a different combination. But in this particular question, it's actually saying that the teams only play each other exactly once, so we can't have those double ups. So our final answer would be 66. Okay, on to our next one. Okay, so it says here is a trapezium ABCD. The area of the trapezium is 66 centimeters squared. The length of AB to the length of CD is 2 to 3. Find the length of AB. So it doesn't give us any information in regards to the height or the lengths. So for this question here, we would have to apply some algebra. So if the ratio is 2 to 3, we could say that the top, let's call it 2x, and the bottom, let's call it 3x. And hopefully we'll be able to solve this and figure out what x is. So when you're doing the area of a trapezium, you take the 2 parallel sides, add them together. So 2x add 3x. Let's just write this down here. So 2x add 3x. You can either times that by a half, or you can divide it by 2. It doesn't really matter which way. I'm going to put divide by 2, and then you times it by the height, and that would give you the area, which we've been told is 66. So can we get the height? Well, looking at this question here, it looks like if we split this down the middle, we do get a right-angled triangle, and we can get the height just there. Now to do that, we're going to use SOHCAHTOA. Now using SOHCAHTOA, that is the opposite, and this is the hypotenuse. And the angle there is 30. So you might actually remember from your exact trig values the value of sine 30. So if you type that into your calculator, if you're not sure, you do get a value of a half. And that means that the opposite is half of the hypotenuse. So this is going to be 3 centimetres. But of course for that, you would just write down your SOHCAHTOA triangle. To work out the opposite, you're going to do a times. So you do sine 30 multiplied by 6, and it gives you 3. So there we go, we get a height of 3. So coming down to our trapezium formula, we're going to times by the height, which is 3, and we get 66. So this is the equation that we need to solve. Now, in order to start undoing this, what we can do is we could divide both sides by 3. That's going to get rid of that times by 3. We can also simplify what's written on the top just here. So that would be 5x divided by 2 is going to equal 66 divided by 3, which is 22. We can then go about solving this, so we can times both sides by 2, and we get 5x is equal to 44, and then we want to divide by 5. So dividing by 5, you get x is equal to, and that is not 4, about to write 4, 8.8. So x is equal to 8.8. Let's go back to the question. It said find the length of A to B. Well, A to B on our diagram is this 2x just here. So if x is 8.8, 2x would be 2 lots of that. So 2 times 8.8 will give us our final answer. Obviously just type that into your calculator, and that comes out as 17.6. So I'm going to put 17.6 just there. I'm happy that I've answered the question. So 17.6 is my final answer. Right, and there we go. And there is area of a trapezium. Okay, on to our next one. Okay, so we've got some laws of indices here, and it's not particularly the nicest of questions. There are different ways of solving this, but let's have a look. Given that 3 to the power of negative n is equal to 0.2, find the value of 3 to the power of 4 to the power of n. Now from this here, this can be written in a different way, because obviously we want to know the value of n. This can also be written in a different way as well, but we'll have a look at this to start with. So 3 to the power of negative n, a negative power can be written as a reciprocal. So we could write that as 1 over 3 to the power of n. Okay, it means the same thing. So 1 divided by 3 to the power of n is equal to 0.2. So for this particular one here, how can we rearrange that to get the power, or 3 to the power of n? Well, all we need to do is multiply both sides by 3 to the power of n, and you get 1 is equal to 0.2 times 3 to the power of n, and then we could divide both sides by 0.2. So 1 divided by 0.2 is equal to 3 to the power of n. Now 1 divided by 0.2 is 5, so 3 to the power of n is equal to 5. Now how does that help us? So this part here says 3 to the power of 4 to the power of n. Now when the numbers are in brackets like that, they're just going to get multiplied together. So what we could do is we could just write them the other way around. We could just say 3 to the power of n to the power of 4. Okay, when you are timesing with those brackets there, you just get 3 to the power of 4n. It doesn't matter how it's written, we still get 3 to the power of 4n. So now we know that you could write this as 3 to the power of n here. We know that 3 to the power of n is equal to 5. So we can just replace 3 to the power of n with the 5. So we would just have 5 to the power of 4. And 5 to the power of 4, which you can type into your calculator, is 625. So there we go. And that is a relatively difficult sort of laws of indices problem there. Okay, so there we go, on to our next question. At the start of the year n, the number of animals in a population is Pn. So we have here some iterations. Now this is an iteration in context. You could have iterations where it's just a purely algebraic approach. So I'll obviously link the full video in the description for this one, because you'll need to know both. Now it says at the start of the following year, the number of animals in the population is p, and then we have the n plus 1. It gives us our iteration formula. So p with the n plus 1 is equal to kpn. Now that just means to get the next number in the sequence, or the next year, we just do k multiplied by the current year. So we need to work out the value of k. It says find the value of the constant k. Now it tells us in 2017 the population was 4,000. And in 2019, the population was 3,610. So there's 2 years difference just there. It goes from 2017 to 2019. So when we're working this out, we would do, and let's just have a look, we take our starting number, which is 4,000. Let's actually write a 4 there, not a 2, which is 4,000 in 2017. We would times that by the value of k, and that would get us to 2018. Then we would times it by the value of k again. Now if we're going to times by k twice, we may as well just write that as k squared, because that's what gets us to 2019. So 4,000 times k squared would then equal 3,610. So we can see that it's going down in value, so this value of k will have to be a 0-point number. So to solve this, we want to get rid of this 4,000. We want to have it just saying k squared. So we've got k squared is equal to 3,610 divided by 4,000. So we could go about simplifying that. We don't necessarily need to. To find the value of k, we need to square root both sides. So we want to know what the square root of 3,610 over 4,000 is. So if we type that into our calculator, the square root of 3,610 over 4,000 is equal to 0.95. So there we go, the value of k is 0.95, which if you remember from depreciation means that it's going down by 5% each year, because that would be equal to 95% of the value, so it's going down by 5%. So the constant k is 0.95. You could write that as a fraction as well, 19 over 20, which is absolutely fine. So there we go, there's looking at some iterations. So this question here, we've got expanding a triple bracket. So it says show that it can be written in the form ax cubed plus bx squared plus cx plus d. So we want to go about expanding this. So I'm going to pick the first two brackets to start with. So 2x plus 1 multiplied by x plus 3. But of course you can pick any two of these brackets. So 2x times x is 2x squared, 2x times 3 is 6x, 1 times x is 1x, and then 1 times 3 is 3. Now before you go and expand it by the next bracket, make sure you do simplify this. So we have 2x squared plus 7x plus 3, and we're going to now multiply that by that third and final bracket. So the last bracket there is 3x plus 7, so we're going to multiply it by 3x plus 7. Now when we do that, we now get quite a lot of pieces here. So we've got, and it's probably worth just leaving a little bit more space, particularly if you use this sort of method. Okay, so expanding these. We have 2x squared times 3x, which is 6x cubed, 2x squared times 7, which is 14x squared, and then onto the 7x. So 7x times 3x is 21x squared, and then 7x times 7 is 49x. We then have the 3 times the 3x, which is 9x, and the 3 times the 7, which is 21. So all we need to do now is simplify this. So we have 6x cubed and the 21 at the end, which doesn't join up with anything else. We've got these 2x squared pieces and these 2x pieces. So we have 6x cubed at the start. 14 add 21 is 35, so plus 35x squared. 49x add 9x is going to give us 58x. And then we have plus 21 at the end, and there we go, there is our triple bracket fully expanded and simplified. Okay, on to our next question. Okay, so we have an algebraic fraction. So it says show that, and then we have these two algebraic fractions being divided. Show that it simplifies to ax, where a is an integer. So we need to actually factorise everything. And don't forget, when we're dividing, we're going to keep the first one and flip the second one over. So if we factorise what's on the left fraction, on the numerator there, that would be 3 brackets x plus 2. On the bottom, we've got double brackets because that's a quadratic. So we are going to have two numbers that times to make 10, and then add to make negative 3. So that should be 1 and 10, or 2 and 5. It's going to have to be 2 and 5 if we're making 3. So that's going to be x plus 2 and x minus 5. We're going to times that by the other fraction, and we're going to do the reciprocal of that. So the numerator, x plus 5, is going to go onto the denominator, and that denominator there is a little bit more complex, so we're probably going to want to factorise that before putting it in. So if we factorise that, at the moment, the only thing that you can factorise out is an x. And if we take the x out, you get x minus, or x squared, minus 25. Now that has also created a difference of 2 squares within that bracket. So we have to factorise that again. So a difference of 2 squares is the same 2 double brackets, but with the different symbols in there. So it'd be x plus 5 and x minus 5. So we actually end up with 3 things. So if we put that onto the top of our fraction, x brackets, x plus 5, and then x minus 5. Okay, so now we just want to see if we can cancel anything. Now as we are multiplying, we can also cross cancel. So I can cancel from the top and the bottom, which we can do here, x plus 2 and x plus 2. I can cancel top and bottom here, x plus 5 and x plus 5. But I can also do a cross cancel with this x minus 5 and this x minus 5 here. as they're all getting multiplied together, they're all going to end up on the top and the bottom of the same fraction, so we're just doing that before we multiply them. Remember, if everything disappears on the top or the bottom, it turns into a 1, so that'll be 1, this will be 1, and then we have a little few bits left on the numerators. So what we end up with is 3 over 1 multiplied by x over 1, which would just equal 3x over 1. Obviously, when it's written over 1, you'd just write that as 3x. So our final answer is 3x, and there we go, it matches what we were told, that it was going to be ax, where a is an integer. Okay, so that was looking at algebraic fractions. Okay, so it says A, B, C, D, E, F, G, H is a cuboid, and we can see the cuboid in the diagram. Then it gives us some information, so it tells us that A to B is 7.3. So let's start labelling these on the diagram. We've got 7.3, C to H is 8.1, and it tells us BCA is 48 degrees. BCA, that's a bit of a strange one. So B to C and then C to A would make this line along the base. And this angle within the base just there is 48 degrees. Right, so that's what we've been told in the information. It says find the size of the angle between A to H and the plane ABCD, and the plane is the base of the cuboid. So between A to H, well, A to H goes up to there. That's a very bad line, let's redraw that. A to H up to there. So there we go, so within the cuboid it actually forms this right angled triangle. So if we draw that in there, we've got a right angled triangle on the inside of the cuboid. So when we're finding that angle, and it says to give it to 1 decimal place, we're looking for this angle just here. Let's label that as x. So if we draw that triangle to the side, this is the triangle that we're looking at. So we're working out this angle here that's sitting on the letter A. We've got the letter H up here, C down the bottom, and this is 8.1. So to get the angle, we can do that using SOHCAHTOA, but we need one of the other lengths. So we can either find the length A to H, or we can find the length A to C. Now finding the length A to H is going to require us probably to find A to C first anyway, so we may as well find the length A to C. So this problem really is just how do we find this length, because then we can use SOHCAHTOA to get the angle. So to get that length there, we're going to have to look at the base. So if I redraw the base, and let's just have a look, we've got A, B, C and D. Now we've already drawn this horizontal line going across, which is the line that we're looking for, A to C. We know that this is 7.3, which means this is also 7.3, and we know that this angle here is 48. So we have two right angled triangles split up on the base. So if we look at the right angled triangle, and let's look at this one here, as that has the angle of 48 in, we can find the length of the hypotenuse. This here is opposite the angle, so we'd use SOHCAHTOA again. So we're going to use sine as it's SOH. So you can draw your formula or your formula triangle. We're looking for the hypotenuse, so we'll cross that out, and then we can find the length of the hypotenuse. So we'd do O divided by S, so 7.3 divided by sine 48. Right, so there we go. So type that into your calculator. So if we type that in, 7.3 divided by sine 48, that comes out as 9.8, and there's a lot of decimals here, so I'm going to write them all down, 23118926. Now that is the length of the hypotenuse. So if we bring that up to the question that we were looking at to start with, we can now replace that question mark with this new length, which is 9.823 and a few more decimals. So now we just need to find the size of the angle. Then we've pretty much solved this problem. So to find the angle, we'll look at labelling it again. So we have the opposite, and this would be the adjacent. So for that, we would use tan. So TOA. So write your formula triangle. When we're looking for the angle, we cross off the T. So it's O divided by A. So to do the working out for this, when we're working out the angle, we'll do the inverse of tan. So our working out would be tan minus 1, the opposite divided by the adjacent. So the opposite is 8.1, so 8.1 on the top, and the adjacent is this big long number here. I'm going to use the answer button in my calculator, as I've left that number in there, But if you've not left it in your calculator, you just have to retype the whole thing back in. I'm just going to put a few dots after that just to show that I'm putting the full number in. So let's put this in. So I'm going to press Shift-Tan, fraction, 8.1 on the top, answer button for the bottom, close my bracket, and we get 39.50849231. Okay, so we're rounding this now to one decimal place, so chopping that after the 5 just leaves us with 39.5, and there we go. So 39.5 degrees is the final answer, and there's some 3D trigonometry. Okay, on to our next question. Okay, so we've got some bounds. So it says here that v is equal to the square root of a over b. A is 6.43, correct to 2 decimal places. B is 5.514, correct to 3 decimal places. By considering bounds, work out the value of v to a suitable degree of accuracy. Give a reason for your answer. So when it says by considering bounds, that means we need to work out the upper bound and the lower bound. And we have a fraction involved. So remember, when we're working out the upper bound with a fraction, we want the upper bound on the top divided by the lower bound on the bottom. And when working out the lower bound, we want the lower bound on the top divided by the upper bound. And that just means for the first one, the biggest possible number divided by the smallest possible, and for the second one, the smallest possible number divided by the biggest. That's going to give us our smallest answer. So we're going to work out both of these. So before I do that, I need to work out the error intervals for both. So for A, and when I'm writing my error intervals here, you can put A in the middle, you can put the number in the middle, doesn't actually matter, but I need to write the error interval for both, and remember, equal to symbol on that left inequality. So for the first one, if we add a 5 on the end for the upper bound, that's 6.435, and it can help to add a 0 onto the end here if it helps you to visualise it, but for the smaller bound, therefore, it would be 6.425. There you go, it's just that extra 5 above and below. For B, you would have 5.514 and add a 5 on, and then we need to take that 5 off, so it'd be 5.5135 rather than 45. And there's our error intervals. So our formula then, putting these values in. So for the upper bound, we're going to do v is equal to the square root of, and we want the upper bound of A, so 6.435, and we want the lower bound of B, so 5.5135. And that's going to give us our upper bound. So typing that into the calculator, square root button, fraction button, 6.435 on the top, 5.5135 on the bottom. So that comes out as 1.080340323. And there we go, there's one of our numbers, and that's the upper bound. So now we'll work out the lower bound. So for the lower bound, I'm going to do the square root of, and now I want the lower bound of A over the upper bound of B. So that's going to be 6.425 divided by 5.5145. And again, just typing that into the calculator. There we go, it's going to go in, I'm going to change those numbers before the 5, press equals, and we get 1.079402689. Okay, there we go. So there are our two numbers. Now what we need to do is we need to think about how we get our final answer. So where it says to a suitable degree of accuracy, I'm going to look at both these numbers. So if I write 1.080340323 and below that 1.079402689. Now what we're looking at is where do they round to the same number? Now I can kind of almost see where that's going to be. But if I do it to 3 decimal places, just there, the first number would round to 1.080. And the second number would round to 1.079. So they don't round to the same number. So I'm going to have to go to 1 degree less. So let's go to 2 decimal places. And now the first number rounds to 1.08. And the second number also rounds to 1.08 because there's a 9 after the line, so the 7 goes up to 1.08. So for my final answer, these are going to both round to 1.08. Now my reason for that is they both round to 1.08. And then we're going to state how they both round to 1.08. So that was to 2 decimal places. You could also use significant figures, but that would be 3 significant figures. So that either means I need to say because they both round to 1.08 to 2 decimal places, or I could say they both round to 1.08 to 3 significant figures. So there we go, 1.08, and you could write your explanation down there as well. There we go, there is looking at bounds. Okay, question 19. So we've got the table shows information about the times a group of students took to do a park run. Draw a histogram for the information. Okay, so the histogram has given us a scale on the x-axis, but it hasn't on the y, where we need our frequency density. So we need to work out the frequency density for all of these. To work out frequency density, you do the frequency divided by the class width. And the class width is the distance between the start and end of each class. So I'm going to write them down just here. I'm just going to label it CW. So for the class width, we have 25 for the first one, 20 for the next one. That's going to be 15 from 45 to 60, 15 to 75, 10 to get to 85, and 10 to get to 95. So I'm going to work out the frequency density by doing the frequency divided by the class width. So for this first one, I'm not going to write the calculation for all of them. I'm going to do 20, the frequency, divided by 25, the class width. So I'm just going to do them on a calculator. So 20 divided by 25 is 0.8. 35 divided by 20 is 1.75. 45 divided by 15 is 3. 87 divided by 15 is 5.8. 10 divided by 10 is 1, and 8 divided by 10 is 0.8. So there are my frequency densities for this histogram. So now I know that the highest frequency density is that 5.8, and that's going to determine how I draw my y-axis, the scale. So I need it to go up to 6. So if we start down here with 0, and let's have a look if we can make it fit with each of those thicker lines every 10 squares. You need to make sure you count those carefully, but that should go beyond 6. So 1, 2, 3, 4, 5, 6. So that's going to fit nicely. So now I just need to draw the bars in. So the first bar goes from 0 to 25 and it has a height of 0.8. So from 0 to 25, and 25 is a bit awkward because on the bottom there, each square goes up by 2. So it's going to be between a few of the squares. So I want to go up to 0.8, which is 2 below 1, and then only halfway through that. I've not actually drawn that halfway, so I'll probably go back. Obviously, when you have a ruler and a pencil, so it's going to be easier for you to draw. Let's see if I can get it. There we go, just about. So there we go, there's the first one. Now for the next one, it goes across to 45. That has a height of 1.75. So across to 45, up to 1.75, which again isn't the easiest of ones to draw. But there we go, I'll do my best. Obviously when you've got a ruler and a pencil, it's a little bit easier. The next one goes up to 3, that's much nicer. And it has a width that goes along to 60. So along to 60 now, that goes up to 3. Almost done. The next one goes up to 5.8, that goes to 75. So 75 goes all the way up to 5.8. Never going to get this drawn perfectly, but I'm going to try just to go a little bit quicker. There we go. Obviously, you want to make sure you use a ruler and a pencil. The next one goes up to 1, so that goes over to 85. So 85 goes up to 1. And there's that one. And then the last one goes up to 0.8, and it's just along to 95 for that one. So that goes up to 0.8, which is the same height as the first bar. It doesn't go all the way to the end of the histogram, just to 95. And there we go, there's our histogram drawn. Not the nicest there to have to draw, particularly that 1.75, that wasn't very nice, and the 5.8 wasn't particularly nice to draw, but not too bad if you have a ruler and a pencil. No additional questions for this histogram, but you could be asked to find averages and things from a histogram as well, but again I'll link that video in the description so you can check out some more histogram questions. Okay, question 20. So it says A, B, C and D are 4 points on the circumference of a circle. It says AEC and BED are straight lines. Where are they? So AEC, this one here, and BED, this one here. There we go, they're straight lines, that's fine, we'll assume that. So prove that triangles ABE, let's just highlight this one, ABE, so this triangle here, and the triangle DCE, prove that they are similar. You must give a reason for each stage of your working. So to prove triangles are similar, we want to prove that the angles are all the same. So how can we use our rule of angles, or any rules of angles, to show that these are similar? Well, the first thing that stands out to me is that this angle here and this angle here are vertically opposite angles. So let's label that one to start with. So that's angle AED. Let's have a look. AEB, sorry. So angle AEB is equal to angle DEC as vertically opposite angles are equal. There we go. And there's our first reason. Now can we find another one? Well, for another angle, we're going to have to apply a circle theorem, and that's our circle theorem when angles are made from the same 2 points on the circumference. So for this one here, and let's draw these in, and it's called angles in the same segment, they create this angle just there, which is in one of the triangles, and they also create this angle just here. So this angle and this angle are equal as well, because angles in the same segment are equal. And as you can see, if I highlight those again, that's another angle within the triangle. So there we go, that's going to prove another angle is the same. So let's write that down. So that's BAE. There we go, let's write this down. BAE is equal to angle, what was it, EDC. EDC. There we go, as angles in the same segment are equal. Or you could say angles, made or subtended from the same 2 points at the circumference are equal. So you could say that as well. Right, so we have proved that 2 angles are the same. So how are we going to prove that final angle? We could actually just use the circle theorem again, but it's easier than that because now we've proved that 2 angles are equal, we know the third angle has to be equal. So as we've proved that 2 angles are equal, we could say, therefore, all 3 angles in both triangles are equal, or all 3 pairs of angles are equal. So all 3, let's change it to pairs of angles because that then, all 3 pairs of angles are equal in the 2 triangles. And if all 3 pairs of angles are equal, then these 2 triangles must be similar. Okay, so all 3 pairs of angles are equal in the 2 triangles. Therefore, and what were the triangles' names? ABE and DCE. So ABE and DCE are similar. And there we go, there's an answer to our question. So when we are proving similarity, we are proving or trying to show that all 3 angles are equal, and we have managed to do that. So there we go, that is looking at some similar triangles inside of a circle theorem. Okay, so moving on to our next question. So question 21, there can't be too many questions left. There are only n red balls and n plus 1 blue balls in a bag. Shamsa takes at random 2 balls from the bag, show that the probability that both balls are the same colour. So remember, obviously with that language there, that means we're going to take one and then take another. So let's draw this probability tree, and it's going to be in terms of algebra. So on the first pick, we're going to take a red ball, or we're going to take a blue ball. Now if we take a red ball, there are n red balls, and there are n plus 1 blue balls. So in total, you've got n and n plus 1, and in total that is 2n plus 1. So that's going to be out of 2n plus 1. So 2n plus 1 on the denominators. Now when we take the next one out, it's going to go down by 1. As we are taking 2, it doesn't say anything about replacement. So for our next one here, we're going to have to think about taking one of them out. So if we take a red out, n will go down to n minus 1. And if we take one out of the total, that plus 1 is going to go, and we'll just have 2n on the bottom. The blue numerator will stay the same as it was, n plus 1, but the denominator is going to stick to 2n. If we took a blue ball out, the blue would go down on the numerator, so that 1 will disappear, it will just be n, and the denominator will be the same as above, 2n. The red numerator would stay the same, it was n before, so it stays as n, and the denominator again is going to be 2n. So there is our probability tree constructed. It says show that the probability that they're both the same colour. So that could be the probability of having a red then a red. It could be the probability of having a blue and then a blue. So we need to work both of them out. So for red and red, that would be n over the 2, that's not an n over 2n plus 1 multiplied by n minus 1 over 2n. So n minus 1 over 2n, and we'll work that out in just a moment. For the green route there that I've drawn for the two blues, that would be n plus 1 over 2n plus 1 multiplied by the n over 2n. So if we multiply those numerators and denominators, on the numerator there it'd be n squared minus n, timesing both of them by n, and the denominator, timesing both of the 2n and the 1 by 2n, would give you 4n squared plus 2n. For the second root, we've still got n squared, but it's going to be plus n on the numerator, and the denominator is going to be the same, so 4n squared plus 2n. So there's our two fractions. Now the probability of them both happening means that we need to add them together. So n squared minus n over 4n squared plus 2n added to n squared plus n over 4n squared plus 2n. Now the denominators are going to stay the same when you're adding the fractions together, so that'd still be 4n squared plus 2n. The numerators, we've got n squared add n squared, which is 2n squared, and then minus n add n just cancels out to 0. So that is our fraction, but it's said here to show that the probability is n over 2n plus 1. So we're going to need to simplify this fraction. Now the top and the bottom both factorise. They're both factorised by 2n. So what we could do is we could write the top as 2n times n, and the bottom we could write as 2n multiplied by, and it'd be 2n plus 1, factorising the bottom there. You don't have to write the numerator like that, but it does make it easier now to cancel the 2n off the top and the bottom to get our final answer. So what we're left with is n on the top and 2n plus 1 on the bottom. And hopefully that matches up to what we've been asked. N over 2n plus 1, yes. So there we go, there's our final answer, n over 2n plus 1. Okay, on to question 22, and I think this is our final question. Okay, so it says solve algebraically the simultaneous equations. So we've got here some quadratic simultaneous equations. It's not the nicest looking one either because we've got a 2x squared here. So what we need to do is we need to use the substitution method. So we need to make this second equation say x or y equals. Obviously looking at it there, it's going to be easier to make it say x equals, as we can just minus 2y to the other side. So if we do that to start with, it'd be x is equal to 1 minus 2y. Now what we can do is we can put this in place of x in that first equation. So I'll put a bracket around it. So all I'm going to do is replace the x with that. Now we do have two lots of that, so it's two lots of 1 minus 2y, that's an x squared, so that bracket is squared, take away y squared, and that is equal to 17. So now that we have that, what we have to do is solve this for y. So we're going to have to expand this double bracket to start with. So I'm going to start by just expanding that double bracket. And you can do that to the side, or you can do it just below. I'm going to do it just to the side here. So 1 minus 2y, and another 1 minus 2y. There we go. And if we expand that, we've got 1 times 1, which is 1, minus 2y, minus another 2y, and then plus 4y squared. And then simplifying these middle two pieces, we've got 1 minus 4y plus 4y squared. And you can always rewrite that with the 4y squared first, completely up to you. I'm going to just put that in place when I rewrite it here. So inside that bracket we have 4y squared minus 4y and then plus 1. And then we've also got the minus y squared equals 17. Obviously this is just a little bit trickier just because we have that 2 on the outside, so we need to double everything in the bracket there. So that's going to become 8y squared minus 8y plus 2, and then minus y squared equals 17. So we'll simplify this down a little bit because we've got the 8y squared and the minus y squared, so we can simplify that, so that'd be 7y squared minus 8y. And we also have this 17 here, which we could minus from both sides at this point. So we want to take that away from the 2, so that gives us minus 15, and that is equal to 0. So at this point here, we can actually solve this for y. We've got to be a little bit careful just to check to see if this factorises. If it doesn't, then you can use the quadratic formula. In fact, even if it does, you can use the quadratic formula at this point if you want. But I think this does factorise. So 7y and 1y, as it's 7y squared, which means when I look at my factors of 15, which can either be 3 and 5 or 1 and 15, one of them is going to get times by 7. But I can see if I times the 1 by 7, I will have 7 and 15, which I can make 8 with in the middle, and we're trying to make negative 8. So if I put the 1 in this bracket and the 15 in this bracket, then the 1 will be multiplied by 7. So how am I going to make negative 8? Well, I'd want that to be plus 7 over here with the plus 1, take away 15. And 7 take away 15 would give me negative 8. So I've got two solutions. I've got y is equal to negative 1 on this one. And for this one, y is going to equal positive 15 divided by 7. So I'd write that as 15 over 7. So there's my two values for y. So not too bad as long as you're happy with all that process. It's obviously a tricky process. We now need to find the values of x. So I have a formula up here that says that x is equal to 1 take away 2y. So to work out x for each of them, I'm going to put them into that formula. So x is equal to 1 take away 2 lots of y. So for the first one, we're going to do x is equal to 1 take away 2 lots of 15 over 7. And for the second one, we're going to do x is equal to 1 take away 2 lots of negative 1. Obviously you can just type these into a calculator. So when we type them in, the first one comes out as x is equal to negative 23 over 7. And for this one on the right, we've got x is equal to 3. And there we go. And there are our x values. So there we go, that is a quadratic simultaneous equation. You would normally pair those values up as well. So I would say when x is equal to 3, y is equal to negative 1. And when x was equal to negative 23 over 7, y was equal to 15 over 7. And there we go, we'd normally write them in pairs, as they are also related to pairs of coordinates. So there we go, that is the quadratic simultaneous equation, and that is the end of the paper. So a lot of questions to have a think through there. Don't forget, obviously, with these topics here, that I will link them all in the description so you can have a look at different variations of each question and different sort of elements of the topic within those videos. Don't forget to check out all the rest of the series and all the other videos related to this particular exam. We're looking at paper 3, and best of luck in your exam. So there we go, hope you found that useful and helpful, and I'll hopefully see you for the next one.